Hey everyone, we are going to be looking at some chords today. So we're stepping away from looking at angles for a little bit. We've been talking lately about inscribed angles and central angles, but today we're going to focus on chords and maybe figuring out how long they can be if we aren't given their lengths already. So what if you have a situation where you have two chords that intersect inside of a circle? How can triangles help me learn something about these chords? You might be thinking, oh no, I thought we were in the circle chapter. Why are we talking about triangles? Because we have so much information about triangles that we can use, it would obviously make sense that we can use triangles to figure stuff out, even if it's in a circle. So let me show you what I mean. Right now we have these two intersecting chords, right? AB and DC intersect at point E. That's their intersection. So what we want to do is we want to create two triangles. Now, there's a couple ways you could create triangles here, but we're going to create triangle BED. So take something straight and connect B and D. And then take something straight and connect A and C as a segment, not an arc. And now you have these two triangles. You have triangle BED and triangle ACE. All right, I could have gone this way and done A to D and also C to B and have two triangles that way. It would have worked the same way. So the next thing we want to do is we want to compare angles B and C. We want to know which one is bigger. All right, well, it's kind of hard to tell because it's not given to us how big they are. However, B and C are both inscribed angles. So let's look at the arcs that they intercept. Angle B intercepts arc DA. And angle C intercepts arc AD. Well, we learned last time that when you have two inscribed angles that intercept the same arc, then those two inscribed angles are going to be congruent. Now, I don't know their exact measure, but I know they're the same. Likewise, if I compare angle D to angle A, angle D is also inscribed. It intercepts arc BC. And angle A also intercepts arc BC. So that tells me that angles D and A are congruent. Well, without even looking at those pairs of angles, I also have these vertical angles here in the middle. So I can say that angle B is congruent to angle C, and I know angle D is congruent to angle A because I know that their inscribed angles intercept the same arc. Now, what does that mean about these two triangles then? They're not going to be congruent. Clearly, they're not the same size. However, we can say that triangle BED is similar, remember the squiggle is similar, to triangle ACE by angle, right? They have at least two pairs of angles that are congruent, so therefore have similar triangles. Although I did not name those properly, did I? Because BED should go with CEA. CEA. Remember, the order is important when you're comparing. So B goes with C, E goes with E, D goes with A. There you go. Now, how does this help us figure out their lengths? Where you have similar triangles, you're going to have corresponding sides that have the same proportion. So here's what you're going to put in your toolkit, right? You're going to copy this picture, and we have segments. We have A and B and C and D. If you were to connect these chord endpoints there and there to make similar triangles, okay, we would have that this angle is congruent to that angle. We've got the vertical angles there, and that's what I'm going to add in for right now because I want you to see which sides correspond to each other, right? So using similar triangles, we know that if you compare A to D, it's going to have the same proportion as C to B. Okay, you can set it up as a ratio like this. However, if you were to then cross multiply, you would see that A times B will equal C times D. So if you multiply down the chord, those two products will equal each other. Okay, let's put this into practice. Let's do a couple problems. I'm going to do 2 with you, and then I'm going to have you do 2 on your own. Okay, so let's look at example number 1. If DE is 8, so let's add that in, and AE is 4, and EB is 6, what is EC? Okay. So if you want to see how this really works, you could draw yourself a nice little set of similar triangles. We know that these angles go together, those angles go together. So if you want to set it up, you could say that 6 over x equals 8 over 4. Okay, so then when you cross multiply and solve, you get 6 times 4 equals 8 times x, which you can see is just multiplying down the chord. This segment times this segment is equal to that segment times that segment, those pieces. So 24 equals 8x, divide both sides by 8, x equals 3. And in this case, EC was what we were trying to find, which is what we were calling x. So EC equals 3. And you can see how that works in proportion. 8 is half of 4, 4 is half of 8, 3 is half of 6. All right, let's look at a little bit more tricky one. I'm going to drop down and do number 3 with you. Okay, again, we're trying to solve for x. You can set it up as a ratio. I'm going to just jump to the part where I set it up as one product equals another product. So I just multiply down the chord. So 9 times 4x and then go down the other chord is going to equal 8 times 4x plus 2. So this is a little bit trickier as far as the algebra is concerned, but not too much. So let's just multiply. 9 times 4x is going to be 36x. Now we have to distribute this 8. 8 times 4 is 32x. 8 times 2 is 16. Take away 32x on both sides, so I get 4x equals 16. Divide both sides by 4, x equals 4. Now, it didn't ask us to find any of the specific lengths. If it had, though, you would have just plugged it back in. So, for instance, 4 times 4, this little part right here is 16. 4 times 4 is 16 plus 2 is 18. Okay, which again, you can see has the same ratio. 8 times 2 is 16, 9 times 2 is 18. Or the ratio of 8 to 9 is the same as the ratio of 16 to 18. All right, press pause on this video and see if you can do examples 2 and 4. Okay, here's what we got. These were a little bit trickier. So for number 2, it gave you that KL equaled 8. So you always have to read up here to see if there's any important information. If KL is 8, and if you take away the 2, KQ has to be 6. So that's the value you would use in your equation. So 3 times x equals 6 times 2. So if 3x equals 12, x must equal 4. For this number 4 down at the bottom, we want to find 2 things, both x and the length of this chord CA. So start by multiplying down the chords. 12 times 4x plus 1 equals 14 times 3 plus 3x. You would need to distribute and you get 48x plus 12 equals 42 plus 42x. Move some things around, 6x equals 30, so x is 5. By plugging 5 back in for your x values, you get that AL is 18. So if you add 18 and 14, you get that CA is 32 in length. What you're going to do now is you have a quizzes assignment. It's linked in the assignment on Unified Classroom. So go ahead and go there. You need to make sure you get at least an 83% correct. So if you don't get it on the first try, go ahead and do it the second time or third time, however long it takes until you get at least an 83% accuracy. Don't worry about speed. You have about 5 minutes to do each question. So speed is not really a huge factor here. Just focus on your accuracy. As always, ask any questions and make sure your quizzes is done by tomorrow at 10 a.m. Thanks, guys. Have a good one.